I'm Albert Lionel, and I want to talk about Learn to Learn computer science. Computer science is difficult, but often our difficulty stems from the fact that we weren't taught good study habits in order to learn this difficult area. So, why is this so difficult? Within the first year, colleges and universities across the nation have notoriously high failure rates. There's a few exceptions in there, but for the most part, people are really challenged. And the reason why is you are tossed into learning a language while also learning a new way of thinking. It's called computational thinking. You look at how to take ideas and abstract them out, how to look at problems and use decomposition or break them into smaller pieces. You look at how to represent data. You look at algorithmic design. And this is within all your first year computer science while you're struggling at just getting the computer to do what you think it should be doing and learning that computers don't always act how we want them to act or do what we do. This whole idea is called divide, conquer, and glue. Take any problem, no matter how large, break it into smaller pieces, solve those pieces, and glue them back together. It's a really powerful way to think, but it isn't necessarily something we all grew up with. Even more to the point, we weren't necessarily taught the skills we need to learn a new way of thinking as we're taking in all the other things that we have to do when we're learning with school. So this series focuses on learning skills. And learning a new skill is exponentially hard if you don't know how to learn. And often we're struggling with computer science because we assume the things that we used to do will work. And that's not necessarily true. The idea of going to class and just learning in class, or this idea of rote memorization, does not work with computer science. It doesn't work with most disciplines. But this is especially obvious when you're learning a new way of thinking. In computer science, we will all struggle. Really, at any point, every computer scientist out there has wanted to take that computer, toss it out the window, and say, I'm done with this. And then they get it working and they get this joy and excitement of getting it to work. But we will all struggle with it. And when we're struggling, it actually means we're growing. It means we are learning. That's not a bad thing to have. So always remind yourself as you're learning this new discipline that if you're struggling, you're actually learning and you're growing. You'll need to learn that a growth mindset is essential. I mean, studies have shown it is actually essential to learning in general. And no matter your background, you can actually catch up with somebody if you keep a growth mindset and you have the resources that you need. But in computer science, we are tied naturally to this growth mindset and how our discipline works. And practice is essential. So what is this series of videos? What are we going to do with this? So we are going to look at learning science, techniques developed by research. And these techniques can actually apply to any discipline, but we're going to apply them specifically to computer science. I'm going to modify them a little bit so they better fit within the domain of computer science, not only to help you learn computer science, but then to continue to relearn, which is a requirement in our field as we progress throughout the years. You'll look at study habits. We'll look at engagement techniques. We'll even look at tools such as the generative AI solutions like ChatGPT and others on how they can help us learn, more so than giving us answers, but how can we use them as a means and way to study and to improve our study habits. We're going to do a lot of exploration learning because computer science is really based in exploration, and we have to really focus on retraining often what we can think are good habits are actually bad habits. So we have to spend some time and effort to retrain those habits so you can become optimal in how you learn information. So before we get to that, I like to usually take a side tangent and say technology is human. Marvin Kranzberg, he did the 6 laws of technology. This is one of his laws, is technology is a human activity. And we're not just talking about computers, we're talking about all technology. So let's think about music. An instrument is a piece of technology. It's created by a human being. A violin, a piano, a flute, a recorder. And by themselves, they don't make great music. You can't set a violin down and say, hey, play some music for me, and it plays some music for you. But the musician who needs to create that music on this violin also doesn't create the music without the violin or the piano or the flute or the recorder. They work in concert together. And that is true of most technology in our world. It is designed to work in concert with the human being. Computers are very much this way. By itself, a computer is a nice brick. But once you involve a human with it, once you involve the programmer, Once you involve these ideas and all these things you're trying to solve in the next best application, then it can do some really cool things. But it takes the programmer and the computer working in concert to create this piece. And so when we think about learning computer science, we actually should think of it as learning music. And that's where we're staying. When we think about computer science, we should think about it as learning music. Programming is difficult. And no one assumes when you learn an instrument that you can learn it by attending class only. They don't assume that you'll sit through a lecture because you sat through a lecture, you know exactly how to play that song. That is silly. We all know this. Everyone knows to learn music, to learn an instrument, it takes practice. Think about when you're in 4th grade and maybe someone handed you a recorder and you sounded horrible at it. You squawked. You could not make a note for the life of you. And some people over the years continued to practice and they became musicians. But you know what was sort of fun at the time? Is we didn't care if we sounded bad. We actually just kept working on it. We laughed, we giggled, and we kept working through the process. And the same is true with computer science. You're going to sound bad at first. It is going to squawk. It's not going to do what you want. But through practice and repetition, mainly outside of class, but through this repetition and this practice, you will be a good programmer and you'll start looking at the world in a different way. You'll start looking at how to solve problems differently. And through what you're learning in class and through the practice and exploration you're doing outside of class, you have the opportunity to be a great computer scientist. And eventually you will create great things, but only if you practice. And keep this mindset that you have to continue to grow, continue to learn, and continue to keep practicing at it, even when you're not in class. So together throughout this series, let's learn to learn computer science. We'll be providing some techniques. I ask you to practice those techniques. I ask you to develop habits around them. And the science has shown that it works. All this is backed by research and science, specifically within computer science. So we're going to be applying these learning techniques to better your understanding of computer science and how you can be successful one step at a time. Thank you.